All right, so in this video, we're going to be proving that the square root of 2 is an irrational number. And to say that something is irrational, we say that it can be represented by the form a over b, where a and b are both integers. So this should be pretty obvious, but this is what we're going to be showing square root of 2 cannot be represented by. And to show this, we're going to do a proof by contradiction. So we're going to say, assume square root of 2 is rational. So going by the definition that we just covered here, that is, it can be represented in the form a over b, where a and b are both integers. So just laying all that out. So we have that we're assuming that it is rational. So it's kind of a setup for a proof by contradiction. And we have this proposition, and we say if it can be represented by the form a over b, then it's rational. And let's also say a over b is in the most simplified form possible. And when we say this, we're saying that there are no common factors in the numerator or denominator. So that is, a and b cannot both be even. And this is because if a and b are both even, say we have 2 over 4, it's always going to have some common factor of 2. This is going to be simplified to 1/2. And any two numbers that are both even and put in the form a over b, where a and b are both even, will have this common factor of 2. So if a over b is in the most simplified form possible, then a and b cannot both be even. So let's keep that in mind and see what we're going to do with that later in the proof. So I'm going to erase this here, just free up some space. So now we set up this equation where we have square root of 2 equals some rational representation where a and b are both integers. So, and this is in the most simplified form, as we've said before. So a and b cannot both be even. Now, let's go ahead and square both sides of this equation. If we square both sides of this equation, we get 2 equals a squared over b squared. We can multiply both sides by b squared and get 2b squared equals a squared. Now, we have 2 times some integer here, right, equals a squared. So that means that a squared is equal to some even integer. And if a squared is equal to some even integer, then that means that a must be even as well. Because if we take the square root of any even number, we're going to get an even number. So a is even. Keeping this in mind, we can represent a like so. A equals 2n, where n is an integer. So we have this, and let's go ahead and plug this back into our equation here, where we have 2b squared equals 2m squared, 2m and all that squared. This is going to give us 2b squared equals 4m squared. We can divide both sides by 2, and we have b squared equals 2m squared. And we find the same thing. B squared is equal to 2 times some integer, because this m squared is an integer times 2 is going to be some even number. So b squared must be even. And following this same logic here, b is even. And here, we've reached contradiction. This is absurd. A and B cannot both be given. And this is all done under the assumption that the square root of 2 can be represented in the form a over b, where a and b are both integers, a rational expression. So we've reached contradiction, assuming that it's rational, showing that they're both even when we know that this clearly can't be the case if a and b is in the form of a most simplified fraction. So we have this absurdity and reached contradiction. So this cannot be true, and the square root of 2 must be irrational. And that's our proof.